any of the assignments thus far? Questions over any of the assignments thus far?
I think I have a question. Does that make sense? Yeah.
Good, Lexi?
How would you start?
Because the carbonation builds up pressure in it.
Yeah, I didn't know that. And like, he was like, "Oh, let me get a drink," and he went across the room.
It sometimes does it with hot water.
Because if the bottle gets hot, because again, water at a certain point will expand. Well, sorry, let me take that back. Because the water, it takes a very high temperature for it to evaporate and expand, but air heats up and expands at a lower temperature. So as the bottle increases in heat, the air inside of it expands, but there's nowhere for it to go because it's a solid container. So it's going to push on the water in the container. And especially if it has a straw, since it's pushing it down, it pushes it back up the straw. So once the pressure is released, it doesn't just dissipate, it's still the air is pushing the water down. So when it finally is able to expand, it expels the water out the straw. So that's kind of why that works. Questions on the homework?
I was confused. I had questions, but I don't know what I had questions. I don't know if I just thought I did this wrong because I got a decimal.
Oh, I had questions on number 3.
So what is the value of B?
B is...
Or BX, yes?
Yeah.
Is there an X?
No.
So it would be not 1, but...
Oh, 0.
I had questions on 3. I just forgot how to do it. Like, that's what we do, right, on our homework?
Yes.
You don't have to graph.
H comma K. So if one of them's missing or not there...
0?
Okay.
Then I have problem 27 on the 2.1. No, I'm sorry. Let me dig it out a while because I believe it's here it is.
So here we want to describe the transformation. So one of them is a vertical
Stretch of
3. The plus 2 inside would be,
the left of 2.
and then
The
does it ask for the vertex?
then identify the vertex. Yep.
The vertex is our H comma K. So the H value from inside would be -2. And that's it. Okay. Now, I want to go on and move on to this here. We can look at more homework questions at the start of class tomorrow. Now, what we're looking at today, 232, because we're doing this in a little bit reverse order, I want to try this section first. Now, we have 2 different forms of this equation. One of them is opening up or down. The other is opening left and right. So in the one version of this equation, we have y equals 1 over 4p times x minus h squared plus k. And for this here, the vertex is the point h comma k. And the axis of symmetry is the equation x is equal to h. And for this first equation here, none of this is new information. because this is what we've dealt with. This is what we've been using. Now, we've not always called it y equals. We normally called it f of x, g of x, but this isn't anything too new. The only new part is that instead of a, we have 1 over 4p. Now, one piece that is new is the focus. The focus is the point h comma k plus p. That piece of information is new. And the directrix is the equation y is equal to k minus p. So the focus and directrix are new, and so is our 1 over 4p. Now the other version of this equation that we have is our x is equal to 1 over 4p, parentheses, y minus k squared plus h. Now the vertex for this one here is the point h comma k. So no matter which equation we have, the vertex is still the point h comma k. It's still going to be the same. Now the axis of symmetry for this one here is the equation y is equal to k. Now the focus for this one here is given to us by the equation h plus p, comma k, and the directrix is given to us by the equation x is equal to h minus p. Now all this information is included in the note sheet at the very start. But the biggest thing I will say, and I've said it before in here, I'm not expecting you to memorize this. I'm not expecting you to memorize these two equations because, again, it is easy to get these switched, to get these flipped, to get parts of these switched around. But I do want you to be familiar with it. Familiar with which general equations go with which one. And on the test, you can have these written down. But if you're not familiar with how this works and how they connect together, it's going to be very time consuming, especially on the test, if you're not familiar with it, with how it works. But if you are, you're going to be able to work these through a lot quicker. And when we look at these today, I am going to be spending a good bit of time on them and really drilling home the point of how it connects with the equation and the information that we have, the general form and what we have. Because if we're given a graph, the y equals is going to be our up or down. The x equals is our left or right, the left or right. So our y equals is our up or down. The x equals is our left or right. Because if we have a graph, we can just look at it and see which one it is. Is it going up and down, or is it opening left or right? The next way that's kind of easy is the axis of symmetry. If they give us the axis of symmetry as x equals or y equals, we can easily determine which one it is. Because if it's x equals, it's our equation with y equals 1 over 4p times x minus h squared plus k. If the axis of symmetry is y equals k, then our equations are x equals 1 over 4p times y minus k squared plus h. Those are kind of easier to look at. We can see the equation. We know which one it attaches to. The same thing's true with directrix. Because if they tell us the directrix is y equals a number, it's not going to give it to us as h minus b, just a number, then it's going to be connected to this first one here. Or if we have x equals a number, it's the second one. We have a direct way to connect those two. And we'll look at how focus and vertex go together here in a minute. But again, with this here, we really need to focus on what information is given and how it connects to the general form. Because if we know what the general information is, what they gave us, and how it connects back, we can do these here. Because what it's wanting us to do is to write an equation of the parabola shown. Now, looking at the graph, does it open up or down, or left or right? It opens to the right, yes? Which equation deals with left and right? So the x equals 1 over 4p times y minus k squared plus h. And again, I'm not requiring you to memorize this formula, but we need to be able to connect the two to each other, the graph and the information given to the equation. Because it's set up this way, we know it's our x equals. Because it's opening left and right, it's x equals. Now, they did give us two pieces of information, the vertex and the focus. Now, looking at this graph, we need to find the x value of the vertex, and it's not 5. So what is the x value of the vertex? It's 6. Because the scale is going by 2s, not by 1s. It is very tempting to say 5. I've had 5 several times today. Now, what is the y value? 2. So it's 6, 2. That is the vertex. We were given that. Now we need to find the location of the focus. So the x value of the focus is, so it's this point right here. So it is 10, and the y value is 2. You're good? Yeah, no, I thought it was 12 for a second too, because of just how they lined the focus up, or how I lined the point up. Questions on how we find the value of the vertex and the focus? Now, looking at the vertex to the focus, does the x values change from the vertex to the focus, or do the y values change? X values change. The y values stay the same, yes? Now, I bring this up for one particular reason, because if I look back to the general form for both of these here, the vertex in both cases is the point hk. No matter which direction it opens, which equation, the vertex is always h comma k. That's how it is. Now, if we look, because we already said that we're using the equation x equals, yes? If I look in this general form, in the vertex form, or vertex part, it's h comma k. For our focus, we have what? H plus p comma k. The second value, the y value, is k in both spots. It is the same. So looking at the vertex and focus, if the y values are the same, and the x values change, because in the vertex it's just h, in this equation it's h plus p. We're adding that value to it. Now that doesn't mean it's always just going to increase, it's going to change. We have not. But I want to bring this up because, again, this is reiterating that this is the correct equation. Because if we look at the vertex, 6, 2, our focus is 10, 2. Which value changed, the x or y? X, because we're going from 6 to 10, yes? The y values stay the same. That's why, also why we know it's x equals. Because looking at the vertex and the focus for x equals, oh, wrong way. Vertex and focus. Well, for the vertex, the y values k and k. 2 and 2, they're the same, yes? But the x value of the vertex was 6, and the x value of the focus was 10. There is a change because we're going from h to h plus p. From the general form, it's saying that there should be a change. There should be a movement from those two there. Do we see how that works? So if the y changed, so here in the other equation, the x value is h in the focus, h in the vertex. It's not changing. It's the same value. But if we look at the y value of the focus, it is now k plus P, and the vertex is just K. It is a certain value for the movement of the focus up or down from the vertex. Now, again, we'll look more into those, especially when we get to them. But that's looking at this here, because if we don't have the graph, we have to look at the vertex and focus to get to the information. But here it gave us a nice chart. Now looking at the equation, X and Y are still going to be there at the end. So the three pieces of information we need are H, K, and P. So if we find the value of H, K, and P, we can find the equation of this parabola. Questions on this so far? Now again, I've said it a few times, we're really wanting to draw a connection from the general forms to the information that we have been given. In both equations, the vertex is stated as the point H comma K. That is the vertex, H comma K. Now the focus for our equation, if we look back at this, is the point H plus P comma K. So I'm going to write that above it. H plus P comma K. So our vertex is H comma K in the general form, and the focus is H plus P comma K. Now, as we connected in the vertex, it tells us H is what? So the value of H is, and K is 2. So, essentially, yes. Now, if we look at the focus, the K value is still 2. That lines up with what we have, yes? Because a variable can't have two different values. We can't say it's 2 and 4. It has to be one exact value. Questions on this so far? Right. Now, so we were saying H plus P is the X value of the focus, yes? What H plus P is what value? 10, yes? Because in the general form, H plus P is taking the place of 10. Now, what is the value of H? So we're saying 6 plus P is, then we can, telling us P is, now again, trying to do this all at once, just looking at the data and jumping straight to the equation can be a little tough, but what did we do? We aligned it with the general information, what we have for the vertex and our focus, and matched up our data, matched up what we have, the H, the K, H plus P, and then solved it from there. Because if we continue to match it up with the general information, it's going to make these problems a lot easier than if we're trying to do this all at once. Do we see this here? Because with 2.3, doing this, no matter if we're going from the equation to the information, vertex, focus, direct six-axis symmetry, or given the vertex and the focus and going back to the equation, if we continue to do this and match it up, we're going to be able to find these. Now what we need to do is actually find the equation. X is equal to 1 over 4. Well, what's the value of P? 4. So we replace P with its value. Y minus, well, the value of K is indeed 2, plus H, which is, now we only have one spot where we need to simplify anything, and that's our 4 times 4. So 16, we have 1/16. Because we're not trying to solve anything, we're just finding the equation. So we need to fix the 4 times 4, and we get this here. And that's it. That is the equation.
Made it seem so simple, even though
Because there is a good bit to it, but if we continue to connect the general parts of this, the focus, our h comma k. Here, the focus, is h plus p comma k, and our vertex, our h comma k, with the information given, and use it to find the values of h, k, and p, plug it back in, we're good. Because we don't need to do more than that, and we really need to connect these two. Questions on this here? Because one of the things that's interesting is once we have these values of h, k, and p, we can find everything else. It didn't ask for this, and this is kind of additional, but the axis of symmetry for x equals is y equals k for this problem here. But what is our value of k? Y is equal to 2. That's the axis of symmetry. Now the new one that we have is directrix. Now the directrix for this one here is x is equal to h minus p. Well, our value of h in this case is, value of p is 4. And 6 minus 4 is, so the directrix for this is x is equal to 2. Well, this here is additional because they just asked for the equation. Well, so the equation for the parabola is this here, yeah. Yeah, you're good. It's an odd word.
I keep wanting to
So the directrix is this here, x equals 2. And the axis of symmetry is y is equal to 2. Now the reason I show you this here is because since we have x, h, k, and p, I just plugged in the given values and solved. Because I looked at the general form and found for the axis of symmetry of x equals y equals k. Plugged in the value k and I got it. Yes?
It's not always going to work out where those.
No. And really, these are two different lines. Because the directrix x equals 2 is actually this line right here, going straight up and down. Now the axis of symmetry y equals 2 is this equation here. Y equals is a flat line, x equals is straight up and down. And it does work out that any point on the parabola, distance to the focus is going to be the same as that distance to the directrix. Those are always going to be the same, incidentally enough. I don't know what that would be exactly, and it would take a little bit to get there because it's not at nice points. Questions on this here? Okay, let's look at this next one here. Now, which direction is this one opening? Up and down or left or right? Left and right. So,
How do you tell if it opens left or right? Like, I can tell that it's left or right, but
It looks like
kind of
right.
like
so it's here it's opening to the right. Which direction is it going?
this way.
Mm-hmm.
oh, like opening.
I imagine it like
Yeah.
about.
So if it was going left, it'd be like this.
Yes.
Oh, if it's going up, it'd be this.
Yes. Mm-hmm. Now again, just like the last one, we need the values of h, k, and p. Because once we get these three values, we can plug it into the formula and get our solution. Now they gave us 2 points, the vertex and the focus. And our vertex is -2, 4. Our focus is the point 2, 4. Now again, the general form for the vertex is h comma k. And if we look back at this one here, the general form is h plus p, comma, k. And again, we're just matching these up. We found the equation because it opened to the right. Left and right is our x equals. Vertex is still h comma k. And the focus, when we have x equals, is the point, excuse me, h plus p, comma, k. Now the vertex does give us some very useful information. It tells us the h value is what? It also tells us the k value is. And our focus, it does agree that the k value is indeed 4, because those are going to be the same. Now it doesn't directly tell us what the value of p is, but we do know that h plus p should equal what? 2. So what is the value of h? So we're saying that negative 2 plus p is equal to? Now we need to solve for p. So we would add 2 to both sides, telling us that p is in a lot of it, in some ways, yes. Questions on this here so far? Because again, when we look at these here, I set it up as x equals because it opened to the right. Left and right is our x equals. Vertex, again, if we look back at the general form, vertex is the point h comma k. I put it in there so that we can see how it connects to that there. The focus, according to the general form, is h plus p comma k. Again, we're just relating this back to the general form. And if we do that, it helps us really organize this and get what we need. Now we need to plug it back in. So we have 1 over 4p. Well, the value of p is 4, so we have 1 over 4 times 4. The value of k is 4, and the value of h is negative 2. So 1 over 4 times 4 is indeed 1/16. And our plus negative 2 is the same as? And that's it. Questions on this here? Questions on any of this here so far? Let's look at this one here. Now, they didn't tell us directly, but the vertex is the point 1, 0. And they did tell us the focus for this here is 1, 0.25.
So this is plus negative 2, or did you say minus 2?
Yes. Now, looking at this one here, which direction does the parabola open? Up. Since we have up or down, our equation is 1 over 4p. Y equals 1 over 4p times x minus h squared plus k. So this time we're not going left or right. We're not using the x equals equation. We're using the y equals. So the vertex is the point h comma k. So our vertex, guys, let's focus in. The vertex is the point h comma k. And because we're looking at y equals, our focus is not h plus p anymore, it's h comma k plus p. So because we're looking at the other one, the focus is a little different. But the vertex still tells us what the value of h is. H is 1. The value of k, 0. And now we need to figure out what p is.
Wait, where's the other point at?
So the vertex, or the focus, 1 comma 0.25.
Wait, how did, sorry, I'm trying to figure out the point of, right there, sorry.
Now the h is still the same, it is 1, because both of them told us h is 1. Now k plus p this time is, so we're saying k plus p is equal to 0.25. Now we know what k is. K in this situation is 0 plus p is 0.25, which is just telling us p is. Now we just need to plug it in, because again, we're relating the general information to the equation that we have. And once we find that, we can plug it back in. Now, we plug in the value of p, 0.25, which just gives us 1 over 4 times 0.25, plus,
Is 4 times 0.25 1?
4 times 0.25 is indeed,
So it'd just be, it wouldn't be 1 over 1, it would just be 1.
so that'd be 1 over 1, or we can simplify it to 1 times x minus 1 squared. But the multiplication of 1 is understood, so we don't necessarily need that. We just have this here, y equals x minus 1 squared. But again, the biggest thing for this is really being able to connect the general forms of these here with our focus, vertex, and the equation itself with the information given. Because if we can connect these two, that's where we're going to be able to solve these and find the equation.
Is this all over 0.25? Or 0.5?
So we're going to finish this